Hello everyone, welcome back to my channel InfoSec Lab and welcome back to our series of attacking and defending AWS services from Try-Hack-Me learning path. So in today's room, we're going to go over one of the core services in AWS EC2 instances. As usual, we're going to go over the concept of what EC2 instances are and then some attacks and some defenses against this AWS service. Alright, without further ado, let's get started, okay? Introduction to EC2. Amazon Elastic Compute Cloud, or EC2, is AWS core computing service. It provides virtual machines called instances running an operating system of your choice. Every instance resides in a private network called virtual private cloud. EC2 meets all the attributes of cloud computing as defined by NIST. EC2 instances are created by the AWS API and take several seconds to a few minutes to fully provision. They run on multiple tenant hardware and, in most cases, can spin up and spin down at a moment's notice. They support per second billing, providing high resolution measure service. With EC2, you only pay for computing resources when you need them. The EC2 instances can be deployed in 26 different geographic regions as of July 2022 across 19 countries and 6 continents. EC2 instances deploy as an instance type. The instance type defines the memory, CPU architecture, which is Intel, AMD, or ARM, and network capacity in combinations optimized for different use cases. As of July 2022, more than 500 instance types are available. Amazon EC2 supports multiple billing models. On-demand instances are the most common one. You pay for what you use and don't pay for what you don't use. When workloads are more predictable, AWS customers can purchase reserved instances in 1 to 3 years term to save money. If you have a workload that can easily recover from an interruption, you can deploy your workload as spot instances and pay below market rates for AWS unused capacity. AWS support Linux, Windows, and even macOS as operating systems. If you don't have already done so, click on the orange cloud details right here, which is this button at the top right, and then generate the cloud environment and use the credentials provided to access the Try-Hack-Me's cloud sandbox. Okay, this is the instructions on how to do so. Right here, you click the credentials button. You will be prompted with the credentials right here. Make sure that the room you have access to environment for the following room. Make sure the room name is correct. And then you click on this credential tab right here. You'll be provided with access key and secret key. Then you just type the AWS configure. That's how you configure your AWS account. Okay, moving on. Launching your first EC2 instance. Let's walk through creating AWS EC2 instance via AWS console. To visit this page, okay. I've already logged in, so it shouldn't matter. Click on the orange launch instances box on the upper right. You'll be taken to a screen to create your instance. For name and text, enter my first instance. Okay, let's do it. Launch instance. Name and text. My instance. Okay. Oh, my first instance. My first instance. For application OS image, Amazon machine image, first select the 64-bit ARM, then make sure that Amazon Linux is highlighted. Okay, so this is the second options right here. This one is selected. This one 64-bit is highlighted. Okay, it looks like it's a default option. Continue. Under the instance type, make sure that tg4.nano is created. This one ARM And then this one instant type is DG4 nano. Okay, so it's been selected right here. Since this is the first time you've launching an instance in this account, you will need to create a new key pair. Click on the blue create new key pair link and complete a dialog. You can name your key pair anything. Select pair PEM or PPK depending on your system. And since I'm on Windows, I should be collecting. No. Since I'm using the Linux machine, then I should be selecting PEM. If you're on the Windows system, you should be using the PPK. Alright, so let's do it. Key pair, create a new key pair. Let's see. Try me EC2 over here, key pair. Create a key pair, and then it will be automatically downloaded to your to your local machine. All right. Make sure the key pair names match the key pair you created. Try me EC2 room. Okay, that's the key pair we have. Under the network settings, ensure allow SSH traffic from, and then okay. Now this one, if I click the option, it's going to show my IP address, which I don't want to reveal. So I'm just going to keep it for now, meaning that I can access the EC2 instance from anywhere. In reality, this is not the best practice because you want to limit SSH access to an EC2 instance as much as possible. So unless you have very important tasks on that specific machine, otherwise you shouldn't have SSH access to that machine. And then anybody who doesn't have any jobs or functions related to that special machine, we should block all the SSH access. But here, because if I click it, it will show my IP address, so I'm not gonna be doing that. Okay, explain the advanced details for IAM instant profile. Make sure the EC2 instant profile is selected. So click here, advanced IAM profile. Select this one. Yes. Instant profile. Okay. And then you can leave the remaining advanced details as default. Review the summary on the right side. Okay. And then we can just create it. So the summary is right here. Number of instance 1, the software IAM. The image to be created on the virtual machine is going to be Amazon Linux AMI. Okay, let's double check one more time. Amazon Linux AMI. Okay, SSC for. Okay, with the i64 ARM architecture, and then the EC2, the instant tab is T4G Nano. How about the security group? Did I miss it? No, I didn't miss it. Okay, cool. And then everything looks correct. Launch instant, and that's how we create an EC2 instant in AWS. We wait for a few minutes, about 5 to 10 minutes, and the instance should be up and running. In the meantime, while we wait for this instance to be created and provisioned, we can continue with our lessons or continue in the room. Connecting to your EC2 instance. This task will discuss the number of ways you can connect to your EC2 instance for administrative purposes, SSH and RDP. The original method for accessing an EC2 instance was over the network via either SSH for Linux or RDP for Windows. This method should leverage the key pair you created in the previous task, which is the try hack me EC2 room. Now, if you kind of forget what was the name you created, you can just navigate here. Let's see, where was it? I think this one, yeah. On the left side menu, on the dashboard, on the left side menu, go to the network and security sections right here, and then under that, click the key pair option. It will show you the key pair that you just created right here. All right, in case you forget it. While there are many ways to connect EC2 Instant using newer service from AWS called the EC2 Instant Connect from all the remaining labs. EC2 Instant Connect provides a browser-based SSH interface to EC2 instances. It leverages temporary SSH public-private key pairs deployed by an agent leveraging AWS IAM permission. The EC2 instance name tryhackme demo instance is set up to work with EC2 Connect. To connect to this machine, go to the EC2 console and select the instance. So dashboard right here, go to the EC2. You see this is the virtual machine that we just created and it was running. No, just stays running, but it's initializing, so it's configuring, provisioning the instance. Now we're interested in this one, tryhackme. If you expand this column, the name is the tryhackme demo instance, which is the one that we're interested in. Click on this one, and then over here on the top right corner we have the connect button. Click that one, and we are presented with these four options: EC2 Instant Connect, Session Manager, SSH Client, and EC2 Zero Console. Alright, let's click Connect on the right side. You want to use a default in most cases, but you can also directly log in as root. Once you hit the connect, the web console will present you with a web-based SSH console like the following. Okay, so over here, after clicking the connect, we are presented with four options, and we are going to try the very first option right here, the EC2 Instant Connect. So when we click the connect one, we'll be presented with a web-based console, and we should be logged in. Okay, cool. Now, in this tab, it also displays all the information of the user that you used to log in. In this case, the public IP address of this EC2 instance is going to be 54.226.253.164, and the username used to log in this case is going to be the EC2-user. We can actually confirm this by using the command who am I on the shell, and EC2 user, that's the one we have right here. Okay. Generally, the URL for Instant Connect is in the form of console AWS Amazon.com is /EC2/version2 connect, and then the username and the instant ID. Let's double check that. Does it display any URL right here? No, it doesn't display any URL. So let's check the URL. Okay, console AWS EC2 Instant Connect. Okay, the URL is a little bit different, but anyway, it's still providing several basic information. The address family is IPv4, connection type is standard, instant ID. So we are provided with instant ID right here. We also have the OS user is equal to EC2 user, and the region US is 1, the port is 22. So yeah, when you try to connect to an EC2 instance via EC2 Instant Connect option. Looking at the URL will provide you several information about such connections. Okay, moving on to the next one, AWS SSM. SSM used to stand for Simple System Manager, but it dropped as simple as they added more and more capabilities to the service. Now it's called AWS System Manager, but still abbreviated as SSM. One of the system management capabilities in SSM is the ability to install a package or run command on a Linux or Windows server. SSM requires an agent to be installed on the host OS, and the EC2 instance must have a correct IAM permission to communicate with the SSM service. In addition to running a command or installing a package, SSM has a third capability called AWS System Manager Session Manager. What a mouthful name that is. Yes, AWS Systems Manager Session Manager. Okay, I guess we're not logging in as using this option, do we? EC2 Zero Console. A new feature to AWS is the EC2 Zero Console. An account administrator must enable the EC2 Zero Console for the region before anyone can use it. Additionally, when using the EC2 Zero Console, you will receive a login prompt unless the instance has a username that has been configured with a password in sc.shadow folder. You cannot log into a machine via the EC2 Zero Console. Okay. Alright, so here's the summary of the major ways to connect to an EC2 instances. We have the direct SSH or RDP. We have EC2 Instant Connect, which is a new feature. SSM Run Command, SSM Session Manager, and then the EC2 Zero Consoles. Now, I haven't worked with Session Manager or EC2 Zero Console, so I'm not pretty sure how exactly they look, but I would say it should be simple enough. SSM Manager, I think there would be more configurations to that one. I'm not sure, but for the other two options, now there's EC2 Zero Console and EC2 direct SSH or RDP connection, we should be familiar with that right now. Like, we've done that so many times. Alright, connect EC2 Instant Connect. Run the ID command to answer the phone. Connect to your EC2 instance via Instant Connect. Okay, so we did. Run the ID and we are logged in as EC2 user. Yes. Now connect SSM Manager, run the command and see what user we connect to. Okay, let's try that. Connect. Who am I? SSM user. Okay. So we are logged in as SSM user. Oh, so I guess it's not simple. It's more simple than the other two, the other options. Using either Instant Connect or SSM Session Manager session, run sudo password root and change the password of the root user. Can you log in with the EC2 Zero Console? Yeah, nay. It should be because we changed the password. Let's try it. Sudo password root. Okay. Sudo password root. I would say testing 1 2 3. Nah. Okay. Testing 1 2 3. Testing 1 2 3. Yeah, I know it's a bad password, but come on, it's just a demonstration. Now we go to the EC2 Zero Console. Connect. Okay. What's next? Okay, let's log in as root and then password is testing 1 2 3. Yay. Who am I? Of course, I'm root. Root. Yes, we can log in. Instance permissions. As we discussed in the IAM rule, EC2 instances have their own way to get AWS IAM credentials in order to interact with other AWS resources. The Instant Metadata Service, or which is short for IMDS, as mentioned in the previous task, one of the services an instance can interact with is SSM. But an EC2 instance can access pretty much any AWS resource if granted permissions. The act of getting AWS credentials from within instances leverage the Instant Metadata Service or IMDS. The IMDS listens on a special IP address 169.254.169.254, part of the AWS hypervisor. IMDS was vulnerable to several server-side request forgery and proxy attacks and was primarily culprit of the Capital One breach. In response, AWS released IMDS version 2 in late 2019. IMDS version 2 leverages a section-based approach to interactions with the metadata service and requires both an HTTP put and HTTP get, making an attack like Capital One a little harder. These next few commands will show you how to leverage the instant metadata service for both version 1 and 2. Okay, we lucky try me demo instance. In order to retrieve the credentials from the security credentials endpoint, you must specify the role name. AWS conveniently provides that via the code to security credentials. Run these two commands to get the role name. Store it in the environment variable role name and echo it out so you can answer the next question. Okay. Okay, let's see. I mean, we're already here, so why don't we just do it? Log into try me demo instance. Okay, let's do it. So we have this command. So we have these two commands. Let's break it out. First, we have this command right here. curl.s, the latest metadata. Okay. So on this EC2 command, curl.s and then http 169.254.169.254 latest metadata. Okay, look what we have. List out everything. We have hostname, we have IAM, we have identity credentials. Interesting. Let's take a look at so what was the URL again? IAM and security credentials. Let's see what it provides. IAM and security credential. Okay, let's run that again. Okay, this is so EC2 instant profile. So the role name, this is the role name. Okay. I wonder what inside the IAM folder. So we have IAM info, course access. Oh, over here it also provides the instant profile, which is EC2 instant profile and also the profile ID, which is more useful. So it's just additional information about the role, the profile. Okay, so I can just copy, paste it here. Okay, so let's run this command. Role name equals to I wonder if the spaces make any difference. No, right? Shouldn't be. .s and http 169.254.169.254 latest metadata IAM security credentials. Okay, echo role name EC2. Okay, so we got it. Now that you have the role name, you can ask the section credentials for the role name. That's simple curl command. Curl this one security credentials and then the role name. Alright, let's try that. No, this one. Yeah, this one. IAM security credential. Role name. Aha! Look what we got. Juicy. Okay, so we got the access key ID, we have the secret key ID, we also get the tokens. Now, remember, this is a token, so it means that this is this account, this profile is using a short-term credentials. If you don't remember what it is, you can refer back to my video on STS, the Credential Labs. So STS stands for Security Token Service, an AWS service that provides short-term credentials for IAM users or roles to assume a certain roles. Okay. Right, so we get the credentials of the EC2 instant profile. Great. Now we should be able. So now because of this feature, Capital One was breached, and then attackers were able to gather credentials and then perform further attacks on Capital One. And because of this, as you can see, this is easy. I don't have to authenticate or I don't have to do anything else. I just simply run the commands. As long as you know the location, as long as you know the command and you know what to look for, everything seems to be easy. And because of that, Amazon decided to release version 2, which requires you to actually authenticate yourself before actually performing these curl commands. Okay, let's see how it does. So now we should enable the IMDS version 2. Enabling this one can be done by EC2 instant you connect to. The following command will be get the EC2 instant ID, echo the value back to you, update the instant metadata options, require a token to make the instant metadata call. So let's do it. So we've got this command right here, instant ID equals to curl.s http, remember no s, okay, 254.169.254 latest metadata. What else do we have? Instance ID, okay. Instance ID echo instance ID. Alright, so we got the instant ID. Do we have it here? No, we don't have that one, so let's save it. Now we can run this command to change the IMDS to version 2. AWS modify instant metadata. EC2 modify instant metadata options. Instant ID. And then HTTP tokens required region. Okay. Modify instance metadata. Okay. AWS EC2 modify instant metadata. Instant ID is here. HTTP token. Forgot. Tokens require. Okay, yeah. Require, and then region is US is 1. Got a typo. You know what? I'll just okay, instant ID is the metadata option. State pending HTTP endpoint enable. HTTP tokens required. HTTP responsible for. Okay, looks like it's been completed. Okay, you know what? Hold on. Let me switch to the EC2 Connect because the interface on this one, the EC2 Zero console, is a little bit inconvenient to follow. So I'm gonna switch to the other connection. Hold on. EC2. Hopefully this one's better. Now, keep in mind that it doesn't really matter what user you log in as because the previous one on EC2 Zero console, we were logging as a root user. This one we're logging as EC2 user. It should be no problem. We should have no problem. Now let's try making the call again. 169.254.169.254 latest metadata IAM and then security credentials. Saw nothing. You see nothing, meaning that we have to have an authenticate. We have to have a token. Okay, so how do we get the token? Here's how you can get the credentials via the HTTP token method. First, you need to get the token. The token is equal to curl, and then you use this curl command to put to the API token right here and update the value of this token. Okay, let's try it. Token is about curl.put latest API token. Okay, latest API token. Copy, paste. Echo token. Okay, we got a token right here. Now with the token, how do we request this curl command using this token? The way we do this is right here. We are going to use the same curl command, but we are going to add a header right here with a token. Let me put it here for you to understand or compare. Oh no, not this one. I'll make this one easier. Yes. So as you can see, this one is the version 1, the IMDS version 1. You can just simply use the curl command and you'll be able to get the role name. But here in version 2, you actually have to include a token in the header right here. So the command is technically the same, everything the same. You just add one more thing, which is the header with a token right here, and we should be able to get the credentials. So let's try it. Okay, role name. Let's double check the command. Equal to curl and then another token. Okay. Equal to name. Yep, we were able to retrieve the role name. If you want to double check one more time, sure, we can do it. Try this one without the token. Echo role name. You see, there's nothing. So yeah. No, this one doesn't have. Echo role name. Cool. Same thing. Now we know the role name, we can actually try to retrieve the credentials. Again, the command is similar. Where was it? It was instant profile equals to this one. Copy the whole thing. And then role. Paste echo instant profile. Oh my god, successful, we got it. Let's try that without the token. Now we shouldn't be able to get anything else, anything out of this command. See? Yep, okay. Echo instance profile. All right, so that's how you exploit the IMDS version 1 of the EC2 instances and how you can mitigate or prevent such attacks from happening in the future. Always update to the latest version of whatever you do, or whatever service, either software or the code or whatever it is, or libraries. Always update to the latest version. Okay. What is the role name attached to your instance? This one, EC2 profile instance. Okay. What was the type of the credential return? What is it? The type is right here. AWS hmark. AWS hmark. Okay. One of the first 4 characters of the IMDS version 2 token return. Echo token. AQAE. AQAE. What HTTP error code do you get when you attempt to meta service without the token? What was the code? I don't know. We didn't. I would assume it's 4.3, but we can try. Doesn't show anything. Either 4 or 1 or 4.3. But how do we figure out? What is this? Oh, dash I. Sorry. Oh, it returns the header. Okay. Alright. So that's how we figure it out. Alright, moving on. EC2 networking and storage. In addition to specifying the instance type, 2 configurable aspects of AWS are networking and storage. EC2 networking. EC2 networking revolves around the Elastic Network Interface, or ENI. All EC2 instances have at least one ENI. However, an instance can have multiple ENIs to act as network device between 2 subnets. For additional network capacity or as a part of failover capability, every ENI has at least one security group attached to it. The security group defines what IP source address, ports, and protocols are permitted to communicate with the ENI. We will cover the security groups in more details when we cover the VPCs in the next room. As part of the AWS network security design, EC2 instances can only send or receive traffic from or destined to the instance. For an EC2 instance to act as a NAT, firewall, or router, you must disable this default source or destination check. Start AWS Cloud Shell from AWS Management Console or this link. So we're actually using the Cloud Shell. I think we can use it over here, AWS EC2 describe network interfaces. Let's see if it works. Okay, it works. You can go to Cloud Shell. I guess we don't need this one anymore. Well, we can actually go here to the Cloud Shell right here and run the same command It's up to you, but I prefer using on my attack box because I have a split screen right here. It's going to be easy for me to going back and forth between the materials and the terminal. AWS JQ network interfaces. This output provides a wealth of helpful information if you're trying to understand the network topology of a target's cloud infrastructure. You get the public IP address, which is this one, private IP address, and the instant ID. But you also get the name and ID of the security group, the subnet, and VPC, which we'll discuss in the room VPC. Please answer the questions 1 in the value of private IP. Please answer questions 1 with the value of the private IP address, association, IP or ID. Okay. Where was it? Private IP address, association. So here, right here, association. IP order Amazon. So the syntax here tells us to go deeper into the JSON file. Start right here. The first key is private IP addresses, and then from this key you go into the association key within that one, and then within this association key you select this key right here, the IP owner ID, and then look for the values of this key. That's what the syntax is for. Okay, what CTO code is the flag you found in the volume? I don't know. Let's go back and continue. EC2 storage. Amazon EC2 uses Amazon Elastic Block Store, or EBS, as the hard disk storage for EC2 instances. These are called the EBS volumes and support multiple types based on the workload. EBS support SSD, HDD, i.e. spinning ladders, and provision IOPS for high performance and mission critical workloads in capacities ranging from 1 GB to 64 TB. EBS volumes can be snapshot for backup and sharing purposes. This EBS snapshot store in Amazon S3 and thus cost much less than EBS volume. Certain EC2 instant types also have ephemeral storage. These SSD drives reside inside the physical machine running the EC2 instance, unlike EBS volumes, which are kept separate from the compute workload for durability. Ephemeral storage is erased when an instance is stopped and restarted. Ephemeral storage does not support snapshots. EBS volume and snapshots can be encrypted using different types of KMS encryption, which we will cover in a future room. EBS snapshots can also be shared across AWS accounts, providing a method of sharing organizationally approved golden images and accidentally sharing data, source code, or secrets with the world. Okay. One way to get access to valuable data is by leveraging EBS snapshots. In this exercise, we'll create a volume for the public snapshot, mount that volume onto the EC2 instance, then read the data from that snapshot. Okay, so first let's take a look at the snapshot we've created in this exercise. AWS EC2 describe snapshots. Snapshot IDs. This is going to be snapshot IDs. Okay, we have the same output. This tells us a bit about what we need to do. We can see the volume isn't encrypted. Where's it encrypted right here? False. No, not a good practice. That will make our job a bit easier. Based on the volume side, we know it's like 1 gigabyte volume. We also know that AWS account has that created this volume is 01918. Aha, okay. The first thing we need to do is create a volume from the snapshot. Important note, snapshots exist in AWS region, but a volume must be in the same availability zone as the machine you will mount it from. We can get the AZ from the EC2 instance from the metadata service. Okay, so now we have to get the service again. Placement availability zone. Let's go back here. What was it? Let's try this one. Placement availability zones. Okay, we see US is 1A, so this is the availability zone of our instance, this EC2 instance. Oops, why did I do that? Okay, US is 1A. What's next? Now we need the volume to create volume for the snapshot. We will specify the GP3 volume type because it's cheaper. Make sure you select AZ from your EC2 instance, okay? We also run on the same EC2, on the same instance. Let's modify the command AWS create volume snapshot right here. Volume, everything is okay. US is 1A, right? Yeah, US is 1A. Now go back. No, not this one. Go back to the EC2 instance. Paste it. Note the volume ID in the above output. We need that to attach the volume to our instance. Okay, we'll check out that later. And then we do the same thing. Note the volume in the upper. We need to attach the volume in the instance. Now we need the instant ID. Okay. Which we've got. Somewhere. Right here. So. Oh, right here. Instant ID is right here. Here's a command we're going to use to attach the volume to the EC2 instance. AWS EC2 attach volume region 1 is device, and then instant ID is going to be this one. Volume ID, vol, and then replace with this one right here. Volume ID. Okay. Let's run it. EC2 instance, paste. Boom, successful. Cool. The first command grabs the instance from. Oh yeah, it just explains what's going on right here. This is what we've already done. So retrieve the instant ID, save it in the variable instant ID, and then we use that to run the following command right here. Okay. Now that we have successfully mapped the volume onto the EC2 instance, we can actually take a look at it. Sudo fthis.l. Sudo fthis-l. And we've seen all the information about this. The disk, entities, device. Alright, what's next? Now we need to create a map point, map the disk, fill the contents of the disk, and discover the flag. Okay, to the sudo make snapshot recovery, and then mount it. Mount it once to snapshot. Okay. Sudo the snapshot recover. Sudo mount, which one? Def and vne. Let's just copy. Paste and then snapshot recovery. Say snapshot recovery. What? 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 PM. What? Okay, where was it? Snapshot recovery flag. It wasn't here. There wasn't anything. What is it? What is it? There's no flag. Did I do something wrong? Okay, what? Sudo make the snapshot recover. Sudo make the snapshot. Sudo mount, and then what was the name of this one? Copy paste. Now it works. Dance like nobody is watching, encrypt like everyone is. What CTO scored in the flag? Mr. Warner vocals. Copy, paste. Okay, moving on next, EC2 configuration. Almost done, guy, almost done. As you saw when you created your first EC2 instance, it the instances are launched from an AMI or Amazon image machine image. Most times you launch an instance from an AWS provide AMI. However, you can custom bake your own AMIs, adding your customizations to a base AMI. These custom AMIs are often used to launch instances in AutoScaling group, a way of quickly scaling your application down or up and down according to customer demand. Excuse me. The final source of IAMs is the AWS Marketplace. Here, you can find AMIs from commercial vendors. The marketplace can contain AMIs that are open source, no license cost, BYOL, bring your own license, or built by AWS via marketplace charges. You can see the AMIs in your account with the command Cloud Shell. So AWS EC2 describe images. Owner Hmm. If you omit the owner's flag, you will see all the public images available in that region. This includes the marketplace images, images from Amazon, and images shared by other AWS accounts. Warning, there are a lot of public images and this command will most likely time out. The TryHackMe AWS development account is this one and is how we share images to our TryHackMe sandbox account. Okay, once of the ways an EC2 instance can be configured at launch time is by user data. User data is a part of the cloud init packets that several public and private cloud providers use. If the user data begins with shebang exclamation mark and then bin bash, the user data is considered a script will be executed by cloud init. User data allows cloud administrators to configure the machines at creation of the environment specific settings. Is the machine part of the dev, staging, operation? Two important things to know about user data. Because it is used for configuration, it often contains secrets or other configuration information useful for penetration tester or attacker. It is executed on boot when it's changed. This means that if you have permission to modify the user data script, you can execute arbitrary commands on the instance when it's rebooted. There are two ways to get the user data. If you're on the EC2 instance or the machine, you can do that with the curl command. Again, this one, IMDS, or look for the var in this fold allocation, var library cloud instances script part 001. That requires using sudo or su or sudo to read the file. Okay. Okay, so now because we are familiar with these commands, I'm just going to copy and paste to save time. But the purpose of typing out is to remember what they are and understand what they are. And AWS is to describe instant attributes. Okay, what does it do? AWS is to describe instant attributes. Okay, attribute user data. So it looks for the attribute of user data in this specific instance where the instant ID is equals to this one. And then the region, the query is user data. And then because this is in base 64, so we have to decode that. The final command takes out the output describe instant attribute called, filters out all the specific field user data, and then pipes that through a base 64 decode to make the shell script readable. Okay, what is the AMI or AMI EC2 instant? For okay, let's try this one first. What is the password written in the file sc? So right here we already got it. sc service config file. User password winner right here. This is the password. Copy, paste. Stack set underline resources regions. Okay, what was the AMIAD? We can try rerunning this command. Yes, and then we look for the name right here. Oh, it's right here. Cool. Wait, was it? We have several. EC2 room capstone secret data instance 22. Okay. How is this? Okay, this one has the account ID. Oh, okay, this is the first one. Where's the image ID? Right. Whoop whoop. Last but not least, load balancers, launch configs, and autoscaling. Most web applications in the cloud are configured to autoscale. The application will spin up or down based on the demand. This demand-based deployment is one of the primary ways companies save money in the public cloud. Rather than purchase hardware for peak demand, they leverage the provider's excess capacity during the peak usage. There are three main components involved in EC2's autoscaling. There are elastic load balancer (ELBs) that broker requests across n number of instances. These load balancers are often triggered to spin up or down capacity. Launch configurations are the instructions for creating new instance. The launch config contains the AMI, instant type, and other critical configurations. The autoscaling group, or ASG, in the AWS is the AWS resource responsible for responding to capacity alerts and creating or terminating instances. From a security perspective, there are a few things to note about EC2 autoscaling. When ASG or autoscaling group scaled out, they scaled out the oldest instance on the fleet. This means that the machine with most exposure to untrusted traffic is the first to be terminated. Only load balancer needs to be publicly exposed. The ELBs check the external traffic and pass it along with the EC2 fleet using the private VPC addressing. Therefore, the EC2 fleet doesn't need to have public IP addresses. Depending on the type of load balancer, it can terminate encrypted TLS connection using the using the free AWS Certificate Management ACM system or ACM system. The second generation of ELBs, known as Application Load Balancers or ALBs, can have an AWS application firewalls attached. This WAF can detect or block common layer 7 or application layer attacks like those defined in WAFs. So these attacks like SQL injection, cross-site scripting, path traversals, or server-side SSRF, etc. Okay, I understand concept. I'm ready to move on. Cool. Conclusion. Now that we've got over the basics of EC2, next room we try to compromise a few EC2 instances and exfiltrate data from a private system. If you have not done so already, please go ahead, terminate this one. Okay. Cool. And that's it for this room. We learned a few of the attack techniques, how to exploit EC2 instances, and some mitigations to those exploits. I hope that after this room, you and me are learning a lot about EC2 instances and how to protect them from the attackers. That's it for the room today, and I hope that if you enjoy watching me struggle, feel free to continue watch my other videos where I also struggle. Otherwise, I'll see you next time then. Thank you very much. Bye.